to the Palmer HWM leak test site, where we do quite a lot of our training for water industry, technicians, contractors, etc. On this site we can create many different situations, from leakage to step testing to flow meter insertions, pressure control, you name it, it can be done on this site. The water actually comes in here through a water meter, so we obviously know when we've actually got real problems or not, plus the fact we can use this for data logging, telemetry logging, any type of logging that we need to do. The actual site itself, it consists of many different pipe materials. We've got MDPE, PVC, smaller diameter, copper, larger diameter, ductile iron. Longest length is probably around 60 meters. I know it's not a sort of great length compared to what the guys have out there in the water industry, but for the purpose of what we're trying to show, at least we can create different situations, different problems, and we gave a lot of thought when we actually designed the site as to the types of problems the guys are going to get when they're out in the field. Effectively, where we've just come from, the water meter actually comes along here, and this is the main valve into the site. So we have one main control valve in, and we have a main artery going right down, and then we have crescents coming off. And the reason that we did that is because we can create situations which happens in the real world, where you actually have a leak noise that will go round and round, and that will in itself cause its own problem. So all our leaks are controlled leaks, basically just a small stop tap and a small piece of pipe, and all the leaks are very small pinholes, so they're not so easy to find. This is a typical leak which we've just been using to do a test on PVC, which you'll see on one of the correlations. It's a very small leak, just a bit of a dribble, but the correlator found it, and it's one that we struggle to find with any other correlator, but the touch in the filter optimization mode actually finds the leak, which we're very pleased about. The new transmitter for the touch, we've changed it slightly. We just used to have one power setting before. We now have a low power and a high power setting, so when you're doing longer distances, 1,000 meters or whatever, clearly you've now got the high power setting as another option. The actual accelerometer, we did a lot of work on this. It's although the correlator is an analog correlator, from our experiences with the digital, we know the types of leaks and things that we want to find and that the digitals are capable of finding. So we put a lot of effort into this accelerometer. It is the most sensitive accelerometer that is out there, and it took us a long time to do the work, and hopefully it's going to find a lot of leaks. Just simply deploy it magnetically, put the transmitter down and activate it. And the last part of the puzzle is just to deploy the red transmitter so that the two can talk to the correlator and hopefully give us our leak position. So both transmitters are now going to send the data back that they're collecting, the leak noise data back that they're collecting, to the correlator. All we have to do is tell the correlator the length between the two transmitters, the type of pipe material, and the pipe diameter. We don't have to worry about filters anymore, because the correlator is going to find the best set of filters in what we call filter optimization, and hopefully that will give us our leak position. With the touch, we're just going to stick it into filter optimization mode, run it and see what happens. So MicroCorr Touch filter optimization. We're on the Palmer leak site on a known leak that we know is troublesome, which is on PVC of around 100mm. The section is only 24 meters long. So we input the details and we leave the correlator to do the work and automatically filter through. Normally we find it takes around
400 seconds before it finds the right set of filters for this particular leak. So now it's done exactly as it did yesterday, and it's moved to the precise leak position, which is actually probably the best result I've ever seen on that particular section of pipe. The pipe is PVC, it's 80mm, and the section is 24 meters long. As you can see here, this is the filter, and this is what it's eventually optimized at, greater than 269 Hertz. Which is quite surprising for PVC. We would have expected it to have probably been lower than that. The elapsed time is 355 seconds. Yeah, I'm going to stop it there.
We're just going to demonstrate the high contrast mode, because one of the problems with colour screens is when you get into bright sunshine, it becomes a bit of a problem to view the screen. At the moment we're in normal colour screen, and we're going to walk into the sunshine and you'll see the difference. As you can see now, it's now becoming more difficult to view. So if we just now go down to the area here, we can now change it into high contrast, which is now much easier to see in the black and white option. From an operator's point of view, at least now we're not having to, we can now turn it into the sun and I can still see it. We can turn it from any angle. May not be so easy in the camera, but from my perspective, I can see it much easier. So we're now in normal colour mode, and it's very, very easy if you're struggling to see it, just to flick into high contrast mode. It takes out all the colours, but at least now you can see the screen much more clearly and you're not struggling. The only things that remain in colour are the transmitters, so we can see which is red and which is blue for obvious reasons, and the SNR, because we need to know at what stage we've got good SNR.